Hello there, amazing people, and all the lovers of chemistry out there. On today's episode of Question for the Day, we have this question that says a 24-gram sample of magnesium reacts with excess oxygen. What is the mass of magnesium oxide, MgO, that is formed? We've been given the balanced equation of the reaction, and we've been given the atomic masses of all the elements, magnesium and oxygen. So let's solve this question step by step. Now, the first thing we were told is that oxygen is in excess. If oxygen is in excess, it automatically means that magnesium is the limiting reactant. Now, under the topic of limiting and excess reactant, it is the limiting reactant that determines how much product is formed. So that means our attention is going to be on the limiting reactant, which in this case is magnesium, and on the product. So from the equation, you can see that we have 2 moles of magnesium, that is 2 ratio, and then 1 mole of oxygen, 1, and then 2 moles of magnesium oxide produced. So we have 2 ratio 1 ratio 2. And since we're focusing on just magnesium and the product magnesium oxide, we have 2 ratio 2. Now, since this equation deals with number of moles, you can see 2 moles of magnesium, and then you have 1 mole of oxygen and 2 moles of magnesium oxide. It therefore means that we need to convert every other detail that is given to us into number of moles. Now, from the question, we have 24 grams of magnesium. So let's convert it into moles. Now we know that number of moles, when you want to convert from number of moles, or when you want to convert from mass into number of moles, we have this formula that says number of moles is equal to mass divided by molar mass. So in this case, we want to convert 24 grams into number of moles. So we don't know the number of moles, but we have the mass, which is 24 grams, and the molar mass of magnesium happens to be 24.31. So therefore, the number of moles will now be equal to 24 divided by 24.31. When we say 24 divided by 24.31, our answer is 0.99. So we have 0.99 moles. So therefore, we can go ahead and now put some things in place. From the equation, we can see that 2 moles of magnesium produces 2 moles of magnesium oxide, MgO. Now we have 24 grams of the sample of magnesium, which we have converted into 0.99 moles. So 0.99 moles of magnesium will now produce an unknown number of moles, x moles of magnesium oxide. So if we cross multiply, we have 2 times x be equal to 0.99 times 2. 2 times x gives us 2x, and 0.99 multiplied by 2 gives us 1.98. So at this point, we can find x by dividing both sides by 2. 1.98 divided by 2 gives us 0.99 moles. So what this tells us is that 24 grams of magnesium, or 0.99 moles of magnesium, produces 0.99 moles of magnesium oxide. But the question says what mass question is what mass. So we are not going to leave our answer in moles. We're going to convert it from moles to mass. And remember our earlier formula, number of moles is equal to mass divided by molar mass. In this case now we're dealing with magnesium oxide. Number of moles is 0.99. The mass we don't know, so let's call it X. And the molar mass of magnesium oxide, MgO, is equal to, magnesium here is 24.31 and then oxygen is 16. When we say 24.31 plus 16, we're going to have 16 plus 24.31. That's 40.31. So we have the molar mass of magnesium oxide to be 40.31. So let's put this formula into use now. Number of moles, which is 0.99, is equal to mass, which is X over here, divided by molar mass, which we have calculated to be 40.31. So this can be over 1. So if we cross multiply, X multiplied by 1 is the same thing as saying X. This is equal to 40.31 times 0.99. So if we do the math, X is equal to 40.31 times 0.99. That gives us 39.907 grams. So in answering that question, they said what mass of magnesium MgO is formed. So 39.907 grams of magnesium oxide is formed. So that's it on question for today. I hope you enjoyed this. Please do well to like, subscribe and share. See you in the next video.